Good morning, students. Write your seat number in the chat box. Yes, we will start. Yesterday, we started the revision of this chapter number 10. The name of the chapter is Halogen Derivatives, which is having weightage 5 marks with option 7 marks. Yesterday also we discussed about this, are there some questions which are asking previous board exams. Now, we will discuss about the very important points and a quick revision we will take. First, I will explain what is meant by halogen derivatives. Halogen, you are very familiar with this word halogen, which are present in group number 17 of the periodic table, which having the elements fluorine, chlorine, bromine, iodine. These are called as halogens. Halogen derivatives means what? I will explain. When hydrogen atoms of aliphatic or aromatic hydrocarbons, you are familiar with this word aliphatic and aromatic hydrocarbons. In 11th standard, we discuss this aliphatic and what is mean by aromatic. Hydrocarbon means these are the compounds which mainly contains hydrogen and carbons. It is called as hydrocarbons. So when the hydrogen atoms are replaced with these halogens, in bracket the halogens are given fluorine, chlorine, bromine, iodine. The resulting compounds are called as halogen derivatives of aliphatic or aromatic hydrocarbons. Then the classification of halogen derivatives. Halogen derivatives of hydrocarbons are classified in two ways. First one, on the basis of hydrocarbon skeleton to which halogen atom is bonded. For example, if the hydrogen atom of alkane is replaced with halogen, it is called as haloalkanes. If the hydrogen atom of alkenes is replaced with halogen, it is called as haloalkenes. In case of alkynes, if the hydrogen is replaced with halogen, it is called as haloalkynes. And if the hydrogen atom of arenes, it is replaced with halogen, it is called as haloarenes. Then some examples are given here. See this first example. This is example of alkane. So one hydrogen here is replaced with halogen. So these are called as haloalkanes. In this alkenes, one hydrogen is replaced here. So these are called as haloalkenes. These are haloalkynes and these are haloarenes. So this is the classification based on the hydrocarbon skeleton. Then second type of classification is on the basis of number of halogen atoms. On the basis of halogen atoms, halogen derivatives are classified as monohalogen derivatives, dihalogen derivatives, trihalogen derivatives, or polyhalogen derivatives. Now, I will explain what is meant by this monohalogen derivatives, dihalogen derivatives. If one hydrogen is replaced, first we will discuss about this monohalogen derivatives. When only one hydrogen, mono means single, when one hydrogen of aliphatic or aromatic hydrocarbons is substituted by one halogen. One hydrogen is replaced with one halogen. It is called as monohalogen derivatives. That is single halogen derivatives. And polyhalogen derivatives means, see here, this is a example is shown here. One hydrogen is replaced with halogen. It is called as monohalogen derivatives. This is aliphatic and this is aromatic. This example is arenes, and this example is this is aliphatic and this is aromatic. Monohalogen compounds means only one hydrogen is replaced with one halogen. In case of polyhalogen derivatives, when more than one hydrogen atoms are replaced, it is called as polyhalogen derivatives. Further, these polyhalogen derivatives are classified depending upon the number of hydrogen atoms replaced. If two hydrogen atoms are replaced, it is called as dihalogen derivatives. If three hydrogen atoms are replaced with halogen, it is called as trihalogen derivatives. If four hydrogen atoms are replaced with four halogen, it is called as tetrahalogen derivatives, etc. Now, we will discuss in detail what is meant by dihalogen derivatives. Di means two hydrogens are replaced with two halogens. So the definition is given here. When two hydrogen atoms of aliphatic or aromatic hydrocarbons are substituted by two halogens, it is called as dihalogen derivatives. See, the examples are given here. CH4, in case of CH4, two hydrogens are replaced with two halogens here, two chlorines. So the name is methylene dichloride, and this is C2H6. C2H6 is ethene. In ethene, two hydrogens are replaced with two halogens. The name is ethylene dichloride. And in case of arenes, see here, one hydrogen is replaced here with X and another hydrogen is replaced with X. So this is example of aromatic and these are the example of aliphatic hydrocarbons. Now, trihalogen derivatives. As the name indicates, trihalogen derivatives means in these three hydrogen atoms of aliphatic or aromatic hydrocarbon is substituted by three halogen atoms. See the example here. See, three hydrogen atoms here replaced with three halogens: chloroform, iodoform. In case of iodoform, in case of chloroform, halogens are replaced with chlorine. In case of iodoform, the hydrogens, three hydrogens are replaced with three iodines. And see, this is example. X means any halogen we can put here: fluorine, chlorine, bromine. Three hydrogens of aromatic system, it is replaced with three halogen. So it is called as trihalogen derivatives. Then tetrahalogen derivatives. Adds it is the definition is same like monohalogen derivatives, dihalogen derivatives, trihalogen. Mono means one hydrogen is replaced. In case of di, two hydrogens are replaced. In case of tetra, four hydrogen atoms are replaced with four halogens. So the example of this, all the four hydrogens of methane, these are replaced with chlorine. The name is carbon tetrachloride. If it is replaced with bromine, it is called as carbon tetrabromide. And in case of aromatic system, see here, one, two, three, four hydrogen atoms are here replaced. So it is called as tetrahalogen derivatives. Then classification, halogen derivatives are also classified the classification of monohalogen compounds only. Now, here we are focusing on the monohalogen derivatives, means only one hydrogen is replaced with one halogen. In this monohalogen derivatives, or it is also called as monohalogen compounds, please mute your mics. Monohalogen compounds are further classified. See, now we are in this chapter, we will discuss about only these monohalogen derivatives. So these monohalogen compounds further classified on the basis of position of halogen atom. कहाँ पे ये halogen atom कहाँ पे attach हो गया है इसके ऊपर classification है. And another classification is the type of hybridization of carbon atom, whether the carbon atom is sp3 hybridized, whether the carbon atom is sp2 hybridized, or whether the carbon atom is sp hybridized. So depending upon this position of halogen and hybridization of the carbon atom, remember here we are uh, only concentrating hybridization of the carbon atom. Alkyl halides, alkyl halides are it is also called as haloalkanes. We will discuss this first, alkyl halides. Now we are very familiar with this alkyl halides. Uh, these are the monohalogen derivatives of alkanes. In case of alkanes, it is also called as alkyl halides or haloalkanes. This is Rx. R is where R is alkyl group and X is halogen atom. So in case of alkyl halides, all the halogens are bonded to the sp3 hybridized carbon atom. sp3 hybridized carbon atom of the alkyl group. Alkyl halides may be classified as primary, secondary, or tertiary. I will explain here. See, when this X is attached to the primary carbon, it is called as primary alkyl halides. When this X is attached to the secondary carbon, just a minute. आवाज येतोय का?
Oh, sir.
Yes, anyone tell me?
Yes, sir.
Because I am in college now today. Today I am conducting the lecture from college, and here some kind of construction work is going on. So sorry for that. So we are discussing about this primary alkyl halides. In case of primary alkyl halides, the X is attached to the primary carbon atom. This carbon atom is primary, this carbon atom is secondary, and this carbon atom is tertiary. Further, I will explain what is meant by primary carbon atom, what is meant by secondary carbon atom, and what is meant by tertiary carbon atom. In 11th standard, already we discussed these primary, secondary, tertiary, but also I have given some examples in this slide also. So primary alkyl halides, see, I will explain in not in detail, but in short, I will explain what is meant by primary alkyl halide. See, when the halogen is attached to the primary carbon atom. Now, primary carbon atom means what? The carbon atom this is the carbon atom which is attached to only one carbon atom. It is called as primary carbon atom. See, so that's why this carbon is attached to only one carbon. That's why it is primary. See, this carbon is also primary because which is attached to only one carbon here, this carbon. And see this carbon is also attached to only one carbon. So this is a N propyl chloride, normal. N is normal propyl chloride. It is straight chain. Isobutyl. Isobutyl, you know, on the second carbon there is CH3 group is attached. That's why it is called as isobutyl bromide. And this is neopentyl. Neo means when there are two CH3 groups on the second carbon. Yesterday also I told you what is meant by this neo. Neopentyl. Pentyl means 5 carbon atoms should be there. 1, 2, 3, 4, 5. So it is neopentyl bromide. So all these examples are the example. All these examples indicates primary alkyl halides. Now we will discuss the examples of secondary alkyl halides. Secondary alkyl halides means in which this halogen is attached to the secondary carbon atom. And secondary carbon atom means this carbon atom is attached to two other carbon atoms. See, this is one carbon atom. See, bromine is attached to the secondary. This carbon is secondary. Why secondary? Because this carbon is attached to one carbon and this is second carbon. So this is isopropyl bromide is a secondary alkyl halide. See, in this example also, chlorine is attached to the carbon atom and this carbon is secondary because this is bonded to, this is first carbon and this is secondary carbon. Second carbon. So the name is secondary butyl chloride and this is a isopropyl bromide. Then tertiary alkyl halides in which the halogen is bonded to the tertiary carbon atom. See, this carbon atom is tertiary because this carbon atom is attached to the another three carbon atoms. So this is first, this is second, and this is third. So this is example of tertiary butyl bromide. Tertiary butyl bromide. Butyl means there are four carbon atoms. 1, 2, 3, 4. And this is the example of tertiary pentyl chloride. Why it is pentyl? Because there are 5 carbon atoms are present. This is 2, 3, 4 and 5. So this is example of tertiary pentyl chloride in which halogen is bonded to the tertiary alkyl halides. Now this is about the alkyl halides. There are 3 types of alkyl halides are explained: primary, secondary, tertiary. Now the second class is allylic halides. Allylic halide means, I will show the example first, then we will understand. See, this halogen is attached to the carbon, and this carbon is attached to the double bonded carbon, means carbon carbon double bond. If such type of situation is there or such type of structure is there, then it is called as allylic halides. Now see the explanation. Halogen atom is bonded to the sp3 hybridized. Sp3 hybridized means single bonded. Sp2 means double bonded, and sp means triple bonded. So this X is attached or X is bonded. See here, clearly it is saying X is bonded to the carbon. This carbon is sp3 hybridized because it is attached to this single bond. If double bond is there, so this carbon is sp2 hybridized. This double bonded carbon is sp2 hybridized, but this carbon is sp3 hybridized. So X is attached to the sp3 hybridized carbon atom, and this carbon atom is bonded to the carbon carbon double bond. See the situation here also. This is carbon carbon double bond, and X is attached to the sp3 hybridized carbon atom. Such type of examples are called as allylic halides. Then benzenic halides, halogen atom is bonded to the sp3 hybridized carbon atom. See, X is attached to the sp3 hybridized carbon atom, and this carbon is atom is bonded to the benzene ring. It's such type of structure is there, it is called as allylic. In these examples also we can see this X is bonded to the sp3 hybridized carbon, and this carbon is bonded to the benzene ring. This is called as benzylic halides. Then vinylic halides, in which the halogen is bonded to the sp2 hybridized carbon atom. See, this halogen is bonded to the, this carbon is sp2 hybridized. Why it is sp2 hybridized? Because it is bonded to the, this is carbon carbon double bond. This is sp3 hybridized. This is also sp3 hybridized, but this carbon is sp2 because halogen is attached to the carbon atom which is bonded to another carbon with double bond. Double bonded carbon is always sp2 hybridized, remember. So here also we can see this is a, these are the examples. This is aliphatic, this is aromatic. In each type, I have given the examples of aliphatic and aromatic also. So, कुणाचा mic चालू आहे, mic. Now, haloalkynes. As the name indicates, the halogen is bonded to the sp hybridized, because in case of alkyne there is a carbon-carbon, there is a carbon-carbon triple bond. See, so this carbon is sp hybridized. This is sp2. This is sp3 hybridized. So these are the different classes of the last one is remaining, that is aryl halides, or it is also called as haloarenes. Haloarenes, in which halogen atom is directly bonded to the benzene ring or sp2 hybridized carbon atom of the benzene ring. Directly, we can see here, X is directly bonded to the benzene ring. Such type of compounds are called as haloarenes or aryl halides. See here. See, when the two hydrogen atoms are replaced, it is a dihalogen derivative of arene. This is also dihalogen derivative. So what is the name? Anyone can tell me what is the name of this compound? This one? You can unmute yourself and tell me what is the name of this compound. You can see this one, first one. Anyone?
1,2 dibromobenzene.
Dibromo?
Benzene.
If you don't know the position, common name, tell me the common name. This is IUPAC name is correct. 1,2 dibromobenzene is correct. sorry, this is 1 and this is 2. 1,2 dibromobenzene is correct. It is also called as ortho. It is also called as, because 1,2 position is ortho position. It is also called as ortho dibromobenzene. This is second one is meta dibromobenzene, and this one, yes, anyone can tell me the name of this compound? Third one, try. This is 1, 2, 3, 4, 5. 1, 2, 3, 1, comma, 2, comma, 3, comma, 5, 1, 2, 3, 5, tetrachlorobenzene. This is the name of this compound, because this is 1, 2, 3, 4, 1, 2, 3, 4. This is the tetrahalogen derivatives. These are the some names of UPSC names of some halogen derivatives are given. So I think you are familiar with this nomenclature system. So just I will take 1, 2 examples and I will proceed. See this one. This one, see. This is CH3, 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 and this carbon is tertiary. So we have to select the longest chain. All the rules are same. We are already seen this nomenclature system in 11th standard. It is what is the name alphabetically, which comes first we have to take first. So this is a 2-bromo 2-methyl propane. This is a 2-bromo 2-methyl propane. For understanding the nomenclature, we have to draw the structure on the paper first. We have to draw the structure on the paper and then give the numbering 1, 2, 3. So see, because the bromine will get the second number here, 2-bromo 2-methyl. On the second carbon, bromine is attached, and also one CH3 is attached. That's why the name is 2-bromo 2-methyl propane. Why propane? Because 3 carbon atoms are in the straight chain. Straight, not straight chain, longest chain. See, this is an example of vinyl chloride. In case of vinyl chloride, this halogen is attached. This is sp2 hybridized carbon. All this is sp. This is sp. Oh, sorry, this is sp3. This is sp3. This is sp3. This is also sp3. This is sp3, sp3, sp3. In this, see this example, in which it is attached to the sp hybridized carbon atom. In this, because it is alkyne. This is sp3. This is sp2. This is sp2, because double bonded carbon is sp2, triple bonded carbon is sp, and single bonded carbon is sp3 hybridized carbon atom. Here it is attached to the, this is benzyl iodide. This is benzyl iodide. See, iodine is attached to the sp3 hybridized carbon atom. This is directly attached, in which iodine is direct. This is example of arene, haloarenes. See, CH3 and iodine, which are at 1,4 position. It is also called as para position. So the name is para iodotoluene. It is the common name. IUPAC name is 1-iodo-4-methyl benzene or 4-iodotoluene also, because when CH3 is attached to the benzene ring, it is also called as toluene. It is also called as toluene. So the name is given here 1-iodo. If it is 1, 2, 3, 4. So the name will be 1-iodo and 4-methyl benzene or 4-iodo. If it is toluene, if it is considered as toluene, it is considered as number 1, because it is special group is considered as number 1. So 1, 2, 3, 4. It becomes 4-iodo toluene. This is a meta dichlorobenzene, or it is also called as 1,3-dichlorobenzene. So this is the homework for you. Write the structures of this. I think you have many of the students completed this homework also. This is a solved example. Draw the structures of all the 8 structural isomers that have the molecular formula C5H11Br. Name each of the isomer according to the IUPAC system and classify them as primary, secondary, or tertiary bromide. So the answer is also given. All these are the 8 isomers having the formula C5H11Br. Such type of questions are for practice. These are not asked for the board examination. Uh, so such type of this question, this I am talking about, this question cannot be asked for the board exam. Remember, but they can ask the write the UPSC name, or they can give the name. We have to draw the structure like this. But such type of bigger question, 8 structures, it is not asked for the exam, but for the practice purpose, it is given. This is also given, right? The UPSC names of the following 1, 2, 3, 4, 5, 6 different structures are given here. So we can uh, first do not see the answers. First write the UPSC names, and for the checking, the answers are also given. And one more question is given here. One more question is given, write the structures of the following compounds. IUPAC names are given and we have to draw the structures. So go through these questions. Then methods of preparation. Next point is methods of preparation of alkyl halides. Means RX we have to prepare. RX, that is alkyl halide from alcohols. So alcohols, the functional group of alcohol is ROH. Variety of alkyl halides are prepared from the various alcohols by the replacement of hydroxyl. This OH is replaced with this X group. We will get these alcohols are converted into alkyl halides. So the OH group may be replaced by the halogen atom by using these. There are 3 types. First one is halogen acids, HX. HX means HCl, HBr, HI, HF. These are the halogen acids. Second one is phosphorus halides. The third one is thionyl chloride or sulfonyl chloride. This is called as SOCl2. Thionyl chloride or sulfonyl chloride. First one, by using hydrogen halides, that is HX. There are 4 types of HX: HCl, HBr. First, we will start from HF, then HCl, then HBr, and then HI. There are 4 types of HX, halogen acids, but reaction with hydrogen fluorides are very fast, or it takes place vigorously, violently. Sometimes it catches fire. So these reactions are not given. Reaction with HF. Reactivity of this HCl and HBr is medium. So in your syllabus, the reaction with HCl and HBr, these are given. First one, and the order of reactivity of alcohols are given. The first, reactivity of tertiary alcohols react fast, then secondary alcohols, and then primary alcohols. Because the carbocation means carbon having the positively charge, it becomes more stable. So tertiary alcohols react very fast. Then secondary, and last one is primary alcohols. ROH, HX, and suitable condition. This is the general reaction shown, how the halogen acid reacts. So detail we will discuss first chlorides and then bromides. First alkyl chlorides. So alkyl chlorides are prepared with the reaction of alcohol and HCl, hydrogen chloride. But only hydrogen chloride, the reaction does not take place, because for the primary and secondary alcohols, we have to use this catalyst. This catalyst, that is a ZnCl2. This catalyst we have to use. Mixture of concentrated HCl and anhydrous ZnCl2. This mixture is very important. This mixture of concentrated HCl and ZnCl2, many times it is asked for the board exam. This mixture is called as Lucas reagent, remember. Lucas reagent means mixture of concentrated HCl and ZnCl2. But in case of tertiary alcohols, this ZnCl2 is not required, because the stability of the uh, carbocation. Because the stability of carbocation, this ZnCl2 is not required. Uh, in the bold type, it is written, but for the tertiary alcohols, readily react with only the concentrated HCl in absence of ZnCl2. So remember this thing, for the primary and secondary alcohols, only we have to write ZnCl2 and concentrated HCl. This process is also called as Gru's process. Remember, this is not included in your syllabus or not included in your textbook, but in NCERT syllabus it is included. Remember what is meant by this Gru's process. Those students who are preparing for the national exams, for example, JEE exam or the NEET exam, remember this Gru's process. This Gru's process is it is same mixture of concentrated HCl and ZnCl2. It is a Lucas reagent and Gru's process. Examples are given: primary, secondary, tertiary alcohols. First one is ethyl alcohol. So ethyl alcohol plus HCl, we have to add ZnCl2, heat. We get here OH is replaced with chlorine, ethyl chloride plus water. Remember, we have to write the byproduct also. For each and every reaction, this H2 is required. Then isopropyl alcohol on reaction with hydrogen chloride in presence of Lucas reagent or ZnCl2 gives isopropyl chloride. Isopropyl alcohol gives isopropyl chloride. This is a secondary alcohol. So secondary alcohol gives secondary alkyl halides. Now this example is very important because in case of tertiary, see this is tertiary alcohol HCl. See on the arrow ZnCl2 is not written here. Only the concentrated HCl reacts with tertiary alcohol and gives tertiary butyl chloride, tertiary butyl chloride in absence of catalyst ZnCl2 because the stability of carbocation, only tertiary alcohols reacts with concentrated. Now alkyl bromides. Alkyl bromides are prepared when HBr is added, but HBr like HCl, we can't store this HBr in a bottle because HBr is unstable. HBr is unstable, so it is prepared at the time of reaction only. It is called as when sodium bromide and H2SO4 reacts, at that instant, at that reaction time, this HBr is prepared. So it is called as in situ preparation. In situ. In situ means it is produced in the reaction mixture. When this sodium bromide and concentrated H2SO4 reacts, HBr is prepared. Uh, and this HBr further reacts with alcohol and this OH is replaced with bromine and we get here bromides. So all the reactions of alkyl mm, previous reaction, chloride reaction and bromide reactions are same. Only the change is here we on the arrow we have to write here sodium bromide plus H2SO4 reflux. For the secondary and tertiary alcohols, dilute H2SO4 is used instead of concentrated H2SO4 as it will dehydrate these alcohols into alkanes. Remember, for the preparation of uh, primary alcohols only, we are using here dilute H2SO4. For secondary and for secondary and tertiary alcohols, we are using dilute H2SO4, and for the primary alcohols, we are using concentrated H2SO4. जर आपण सेकंडरी आणि टर्शियरी अल्कोहोलसाठी कॉन्सन्ट्रेटेड H2SO4 वापरलं तर डिहायड्रेशन रिॲक्शन होऊ शकते. डिहायड्रेशन म्हणजे H2O रिप्लेस करण्याच्या ऐवजी वॉटर मॉलिक्यूल रिमूव्ह होऊ शकतो. लक्षात घ्या, म्हणजे अल्किन बनू शकतो. म्हणून ही गोष्ट लक्षात ठेवा. Remember this note is very important because this 1 mark question can be asked on it. In case of preparation of alkyl bromides, dilute H2SO4 is used for the secondary and tertiary alcohols. Why? Why dilute H2SO4 is used for this preparation of bromides, alkyl bromides by using alcohols? असा प्रश्न तुम्हाला विचारू शकतात. लक्षात घ्या. सो रिमेंबर दिस रिझन. if the concentrated HCl concentrated H2SO4 is used Instead of replacement, it will gives dehydration, means water molecule will be removed. See here, it is isopropyl alcohol on reaction with HBr. See, this is a secondary alcohol. So this H2SO4 is dilute here, and this H2SO4 is concentrated. Remember, it is not written, but in case of primary alcohols, it is concentrated, and in case of secondary alcohols, this H2SO4 is dilute. Remember, this H2SO4 is dilute. Other process is same. Isopropyl alcohol, this OH is there. So this OH is replaced with bromine. In case of tertiary alcohols also, we have to use here dilute H2SO4. Remaining reactions are same. This OH will be replaced with this bromide. So this is a tertiary alcohol. We will get tertiary bromide here. Then alkyl iodides. Alkyl iodides are prepared by heating alcohols with sodium or potassium iodide, NEI or Ki here, sodium or potassium iodide in 95% phosphoric acid, H3PO4. Here also HI is generated in C2. Here also HI is also unstable like HBr. It is not stored in the bottles like HCl. HI is also prepared in the reaction mixture, this NEI and H3SO4. And other all the reactions are same. This iodine will be replaced with OH will be replaced with iodine. In this reaction, phosphoric acid is used instead of concentrated H2SO4 because this reason is very important, because H2SO4 is an oxidizing agent and HI is a strong reducing agent. In this reaction, we can see here H3PO4 it is used. H3PO4 it is used instead of concentrated H2SO4 because concentrated H2SO4 is a oxidizing agent and HI is a strong reducing agent. HI reduces sulfuric acid. See, HI काय करतो? HI reduces sulfuric acid to sulfur dioxide and itself get oxidized to iodine. Okay, for avoiding this step, we have to use here phosphoric acid instead of concentrated H2SO4. See, because in this reaction, the HI will be generated by using this, and HI is a reducing agent. H2SO4 is a oxidized agent. What will happen there? HI will reduce the sulfuric acid to this oxide and itself get oxidized to iodine. So avoid this step. We are using phosphoric acid instead of concentrated H2. This question can be asked for the board exam, remember. Note this question: for the preparation of alkyl iodides, why H3PO4 or why phosphoric acid is used instead of concentrated H2SO4. So we have to write this answer here. We have to write HI is a strong reducing agent and H2SO4 is oxidizing agent. HI will reduce the sulfuric acid to sulfur dioxide and itself gets oxidized to iodine. Then next one, methods of preparation of alkyl halides by using phosphorus halides. Phosphorus form two types of phosphorus halides. One is PX3 and PCl5 here. PCl5, PX3 here, reaction with phosphorus trihalide. We will discuss first this trihalide. Alkyl chlorides are prepared by refluxing alcohols with